Hello everyone, welcome back to Olsen Cafe. Now in this lesson, we are going to solve question involving greatest angle of elevation. Now over here in this applet, right, what we observe, all right, will be the relationship of the angle of elevation of the top of the tower, right, versus the angle of depression, right, from the top of the tower. All right, you will see that both angles are actually equal. Now, but what we will like to observe, all right, is when the angle of elevation will be the greatest. So I am going to move, all right, this point, all right, up and down along the purple path. So what I would like you to observe, all right, is how the angle of elevations and depressions, all right, changes. All right, so say I start from the motions here, the purple path. All right, so we will see when will the angle be the greatest. All right, so you notice that the angle is, all right, slowly increasing, all right, until it reach 40.1, and then the angle start to decrease again. All right, so which means from here, all right, I'm able to guess and to know that the greatest of angle of elevations and depression, it is actually at 40.1 degrees. All right, any point beyond or below this point, all right, the angle will be less than 40.1 degrees. Now, unfortunately, in this applet, I am not able to show you, or what is the angle, all right, of the orange, all right, angle there. So, but let me, all right, show you, all right, from a different perspective. All right, let me move this applet and to show you. Okay, let me stop here. All right. So from here, I am not able, all right, I'm not sure if you are able to see, all right, the relationship between, all right, the line from the base of the tower to the purple path. All right, so this angle in orange here, all right, you can see from here it is actually 90 degrees. All right, so which means at this point, to give us the greatest of angle of elevation and depression, all right, it is actually the point, all right, that is 90 degrees from the tower. So this point here, all right, I will say that it is shortest distance from the base of the tower to the purple path. All right, so this is an important observation, all right, that all of us must have, right, in order for us to find the greatest angle of elevation. All right, so which means I hope you're able to see the relationship. To find greatest of angle of elevation, it is actually at the point whereby it is shortest distance away from the base of the tower. Once we are able to see this relationship, then we are able to solve the questions. So now that we know greatest angle of elevation is linked to the shortest distance of C from AB, and we are ready to apply this knowledge to solve these questions. So over here, what we see, all right, is that we have a triangle ABC, all right, and based on here, we are required to find the greatest of angle of elevation, all right, from this tower T, all right, view from the path, all right, along AB. So this is what we want to find. Yeah, so based on this, right, we already know, all right, to find this, all right, the greatest angle of elevation, right, it can be found on this point, all right, which is over here. All right, so let me name this point F. All right, so basically shortest distance can be found, all right, from point F. Yeah, so this point F, why I call it point F, all right, this is called the foot of the perpendicular line, all right, from C to AB. Now, so how can we find this? So therefore, what we need to know is that shortest distance, it is also the distance, let me call this a D, right, which means I know that D is actually perpendicular to AB. Yeah, so once I have this, all right, I know that this is 90 degrees, and then we are ready to solve the question. All right, now so let's take a look at all right, the diagram here. So basically what we need to do is, before we can find the greatest angle of elevation, right, we need to find the shortest distance first. So there are two steps to this question. So what we are going to do is, all right, I am going to look at the first triangle. All right, so this first triangle here that I'm going to take a look, it will be this triangle here. All right, earlier on I have already labeled this point, all right, as F. So that means I want to look at this triangle A, C, and F. So to solve this, what I'm going to do is I am going to draw out this right angle triangle. So I have this as A, C, and F. All right, so what do we have? Which means I want to find this shortest distance, which is D. All right, and what I have here, all right, this is equals to 42 degrees. All right, what else do we have? All right, you notice in the diagram, all right, we are given that AC is equals to 70. All right, so based on this, I am able to solve for D. And since what we have here is a right angle triangle, so therefore we are simply just going to apply tuakaso. All right, so based on this, if I'm going to write down tuakaso, all right, so based on this, right, tuakaso, so what I have here is I have the angle, I have opposite and hypotenuse. So opposite and hypotenuse, so that means I'm going to use so which means what I'm going to have here is I'm going to have sine 42 degrees. This is equals to opposite over 70. And with this, what is D? D is equals to 70 times sine 42 degrees. Yeah, so if you use a calculator, all right, you can simply get the answers, all right, which is equals to 46.839. Yeah, so this will be, all right, the distance for D, or I can also just leave the answer as 70 sine 42. All right, I can just use that to sub into the, all right, equations later on. So now that shortest distance is found, I am ready to find the greatest angle of elevation. Now to find greatest angle of elevation, so what I'm going to do is I'm going to look at the other triangle, all right, which is this triangle here. Okay, so this triangle, I am going to draw it out. So this will give us, all right, another right angle triangle. So this right angle triangle now, this will give me the tower, which is T, and then the base, which is C, and then this foot here. So this one is F. All right, so the greatest angle of elevation, which is this angle here, this is our theta. So I want to find this. And what do I know? All right, I know that the height of the tower is 57, and I have already found what is D. All right, so this D is what we have found, all right, from the first part. So therefore, by looking at this, again, I'm going to use tuakaso. So what do we have? All right, I have opposite sides and I have the adjacent. So opposite and adjacent, so which means I know now I am going to apply tua. So by using tua, that means I will have tangent theta. All right, this is equals to 57 divided by 46.839. So with this, if I'm going to just use a calculator and work out the answers, all right, so let me just write this down. So with this, all right, I input the values into the calculator, I will be able to get the theta, which is equals to 50.6 degrees. So this is our answer. So therefore, in this case, the greatest angle of elevation for this question is 50.6 degrees. All right, so hope you find this video useful. So in short, all right, for questions like this, in order for you to find greatest angle of elevation, all you need to do is identify where is the shortest distance, all right, from the point. Yeah, so once you're able to identify these two, all right, you can solve any kind of questions like this very easily. All right, so also do take note, if the question asks you to find greatest angle of depression, it is exactly the same as how you find greatest angle of elevation, because All right, angle of elevation and angle of depressions, they are exactly the same. All right, so I hope with this, all right, you'll find this useful, and I will see you in the next video. Bye.